Q21. A data engineer is working on an ad hoc analysis task that involves combining data from two existing tables in a Databricks environment. The resulting relational object is only needed for the current session and should not be shared with other users. To minimize storage costs, the engineer wants to avoid creating or persisting physical data. Which type of relational object should the engineer create? A. Spark SQL table. B. View. C. Delta table. D. Temporary view. The correct answer is D. Temporary view. Why this is the right choice. Session scoped. A temporary view in Databricks Spark SQL is explicitly tied to the current Spark session. Once the engineer closes their notebook or the session ends, the temporary view is automatically dropped. Zero storage cost. Unlike physical tables, like a Spark SQL table or a Delta table, a temporary view does not persist any data to physical storage, like Cloud Object Storage or DBFS. It simply stores the query definition in the session's catalog and computes the result lazily when called. Privacy. Because it is scoped to the specific session, it cannot be seen or accessed by other users or across different clusters, perfectly matching the requirement that it should not be shared. Why the other options don't fit. A. Spark SQL table and C. Delta table. Both of these are physical relational objects. They write data files to disk, which incurs storage costs and makes the data permanently available to other users with access to the catalog. B. View, standard/global. A standard view is persisted in the Metastore catalog. While it doesn't store the underlying data physically, the definition itself is permanent and visible to other users across different sessions until it is explicitly dropped. Q22. A data engineering team is preparing a consolidated retail dataset for quarterly reporting. They have two tables, June_transactions and July_transactions, each containing distinct records from their respective months. There are no duplicate entries between the two tables. The team wants to create a new table called all_transactions that includes every record from both months without introducing duplicates. Which SQL command should they use to achieve this? A. Create table all_transactions AS, select asterisk from June_transactions, inner join, select asterisk from July_transactions. B. Create table all_transactions AS, select asterisk from June_transactions, union, select asterisk from July_transactions. C. Create table all_transactions AS, select asterisk from June_transactions, outer join, select asterisk from July_transactions. D. Create table all_transactions AS, select asterisk from June_transactions, intersect, select asterisk from July_transactions. The correct answer is B. Create table all_transactions AS, select asterisk from June_transactions, union, select asterisk from July_transactions. Why this is the right choice. Combining rows vertically. The union operator is used to combine the result sets of two or more select statements into a single result set, stacking the rows from both tables vertically. Handling duplicates. By default, union removes duplicate records between the datasets. Even though you already know there are no duplicates between June and July, union safely ensures a clean, distinct consolidation while adhering to valid SQL syntax. CDS pattern. This statement perfectly follows the create table as select CDS pattern to instantly build and populate the new all_transactions table. Why the other options don't fit. ANC. Inner join/outer join joins are used to combine columns from different tables horizontally based on a matching key, like a shared user ID or transaction ID. They do not append rows vertically. Furthermore, nesting a second select asterisk directly after a join operator without an on clause is syntactically invalid. D. Intersect. The intersect operator only returns rows that are common to both queries. Since the prompt states that the tables contain distinct records from their respective months with no duplicate entries, an intersect will return a completely empty table. Q23. You're supporting a data engineering team that has built an ETL pipeline using Delta Live. Table to process travel reimbursement records. The business rule mandates that if an employee's location details are missing, the pipeline must terminate rather than continue processing invalid data. You need to define the constraint behavior to enforce this rule during data ingestion. How can the scenario be implemented? A. Constraint valid underscore location expect location equals null. B. Constraint valid underscore location expect location equals null on violation fail update. C. Constraint valid underscore location expect location equals null on drop row. D. Constraint valid underscore location expect location equals null on violation fail. The correct answer is B. Constraint valid underscore location expect location equals null on violation fail update. Why this is the right choice? In Delta Live Tables, DLT, expectations are used to define data quality constraints. When you need the pipeline to completely terminate and stop processing immediately upon encountering a bad record, you use the on violation fail update clause. The condition, expect location, equals null ensures that the location field must contain data to be considered valid. The action, on violation fail update, tells DLT that if any record violates this condition, the pipeline execution must immediately fail and abort the update, preventing invalid data from being processed further. Why the other options don't fit? A. Constraint valid underscore location expect location equals null. This condition is backwards. It would expect all locations to be empty, failing the pipeline for valid records. Furthermore, it completely lacks an action clause, like on violation. C. Constraint valid underscore location expect location equals null on drop row. This uses incorrect syntax on drop row instead of the correct DLT syntax on violation drop row. Even if syntactically correct, dropping the row would silently discard the bad data and allow the pipeline to continue running, violating the mandate to terminate. D. Constraint valid underscore location expect location equals null on violation fail. This is close, but it is incomplete syntax. In Delta Live Tables, the keyword update must follow fail to construct the valid command on violation fail update. Q24. A data engineer is troubleshooting a Databricks job that executes two notebooks as separate tasks. During the current run, one notebook is performing slower than expected. The engineer escalates the issue to a tech lead, who needs to inspect the job's UI to determine the cause of the slowdown. Which approach can the tech lead use to identify why the notebook is running slowly as part of the job? A. Go to the Runs tab in the Jobs UI and review the notebook without selecting a specific run. B. Go to the Tasks tab in the Jobs UI and select the active run to inspect the notebook execution. C. Go to the Runs tab in the Jobs UI and select the active run to inspect the notebook execution. D. Go to the Tasks tab in the Jobs UI and review the notebook without selecting a specific run. Q25. A data engineer is implementing a structured streaming pipeline using Apache Spark to process incoming data in microbatches to ensure fault tolerance and accurate recovery in case of failures. The engineer wants to understand what mechanism Spark uses to record offset ranges during each trigger so they can track progress and reprocess data reliably. What mechanism is used by Spark to achieve this? A. Checkpointing and write-ahead logs. B. Replayable sources and idempotent sinks. C. Write-ahead logs and idempotent sinks. D. Checkpointing and idempotent sinks. The correct answer is A. Checkpointing and write-ahead logs. Why this is correct? Spark structured streaming achieves internal fault tolerance and reliable tracking of microbatches by combining two distinct but interrelated mechanisms. Checkpointing. Spark saves metadata regarding the stream's overall progress to a persistent, reliable storage location like HDFS S3 or ADLS. This metadata includes the specific execution plans, state information for stateful operations, and the exact offsets that have successfully finished processing. Write-ahead logs, WL, before microbatch is actually processed, Spark writes the target offset ranges for that trigger into a write-ahead log. If the streaming application crashes mid-batch, Spark reads this log upon restart to know exactly where the failure occurred and what data needs to be deterministically reprocessed. Why other options are incorrect? Replayable sources and idempotent sinks. B. C. D. While replayable sources like Kafka and idempotent sinks like Delta Lake are mandatory to achieve end-to-end exactly one semantics, they are properties of the external components. They are not the internal mechanism Spark itself uses to physically record and track offset ranges per trigger. Q26. A data engineer is building a reusable data entity by combining multiple source tables. This entity needs to be accessible across sessions by other engineers and must be saved to a physical location for persistence and sharing. The engineer is evaluating which type of data entity best meets these requirements. Which data entity should the engineer create? A. Table. B. Function. C. View. D. Temporary view. The correct answer is A. Table. Why this is correct? To meet all the requirements specified by the engineer, the data entity must be a table. Physical location for persistence. A table writes both its metadata to the metastore and its actual underlying data to physical storage, like a cloud object store or HDFS. This ensures the data is permanently saved. Accessible across sessions. Because a table is registered in the shared catalog, it persists even after the current Spark session or cluster shuts down. Other engineers can query at any time from their own sessions, combining multiple sources. You can easily create a table from a complex query combining multiple source tables using syntax like create table my_NDAS select. Why other options are incorrect? View. See, while a standard view is accessible across sessions, it does not save the data to a physical location. It only saves the text of the SQL query. Every time another engineer queries a view, Spark has to reevaluate and recombine the underlying source tables from scratch, which does not satisfy the requirement to be saved to a physical location for persistence. Temporary view. A temporary view is scoped strictly to the specific Spark session that created it. As soon as that session ends, the view disappears, meaning it cannot be accessed across sessions by other engineers. Function. A user-defined function, UDF, is an executable block of logic used to transform individual data points. It is not a structural data entity used to store or combine multiple data tables. Q27. Your enterprise data team is migrating from a legacy data lake to a modern lakehouse architecture to improve governance and reliability. During the transition, they're evaluating which feature of the data lakehouse contributes most to enhancing data quality compared to the traditional setup. Which feature should they prioritize? A. The lakehouse retains files using open standards for compatibility. B. The lakehouse enables the use of SQL queries to examine data. C. The lakehouse accommodates both tabular and non-tabular data types. D. The lakehouse supports ACID-compliant transactions. The correct answer is D. The lakehouse supports ACID-compliant transactions. Why this is correct? In a traditional data lake, files are written directly to distributed storage without any transactional boundaries. If a write operation fails halfway through, it leaves behind corrupted or partial data, directly degrading data quality. By bringing ACID atomicity, consistency, isolation, durability, transactions to cloud object storage via table formats like Delta Lake or Apache Iceberg, the lakehouse ensures all or nothing writes. Fail-safes prevent partial or corrupted data from ever being exposed to downstream users. Isolation. Readers will never see uncommitted, dirty data from concurrent write operations, ensuring a reliable and high-quality source of truth. Why other options are incorrect? Open standards compatibility, A, and tabular/non-tabular data support. C, while these are defining characteristics of a lakehouse that prevent vendor lock-in and enable flexible workloads, they provide flexibility and storage variety rather than directly enforcing data quality. SQL query capabilities. The traditional data warehouses have always used SQL queries, and many legacy data lakes use engines like Hive or Presto to do the same. Being able to run a query does not inherently improve or guarantee the underlying quality of the data being read. Q28. A data engineering team is designing a multi-layered Lakehouse architecture to support analytics workflows. They are reviewing the relationship between bronze and silver tables to ensure proper data refinement. Which statement about the structure and purpose of silver tables compared to bronze? Tables is always valid? A. Silver tables store raw and unclean data compared to bronze tables. B. Silver tables always include aggregated metrics, while bronze tables do not. C. Silver tables always contain a larger volume of records than bronze tables. D. Silver tables represent a cleaner and more refined version of the data than bronze tables. The correct answer is D. Silver tables represent a cleaner and more refined version of the data than bronze tables. Why this is correct? In the standard Medallion architecture used in modern data lakehouses, data flows through a pipeline of refinement. Bronze layer acts as a landing zone for raw, unclean data. It preserves the source history in its original format with minimal to no modification. Silver layer takes the data from the bronze layer and applies cleansing, filtering, schema enforcement, and deduplication. The goal is to provide an enterprise-wide single source of truth that is high quality, trusted, and ready for analytics. Thus, silver is always a cleaner and more refined version of bronze. Why other options are incorrect? A is inverted. Bronze tables store raw and unclean data, while silver tables store clean data. B is incorrect. High-level aggregated metrics and business logic are typically reserved for the gold layer, the final presentation layer. Silver tables generally keep the data granular, but clean. C is incorrect. Because silver tables undergo deduplication, data cleansing, and filtering out corrupt or irrelevant records, they often contain a smaller or equal volume of records compared to bronze, not a larger one. Q29. A data engineer working on a Spark-based analytics platform executes the command drop table if exists my_table to remove a table. After running the command, they observe that both the data files and metadata associated with the table have been removed from the file system. What explains this outcome? A. The table was created as a managed table. B. The total size of the table's data was under 12 gigabytes. C. The total size of the table's data exceeded 12 gigabytes. D. The table was created as an external table. The correct answer is A. The table was created as a managed table. Why this is correct? In Apache, Spark, and Hive catalogs, tables are classified into two main types based on how their storage lifecycle is managed. Manage internal tables. Spark manages both the metadata in the Metastore catalog and the underlying physical data files. When you drop a managed table using drop table, Spark automatically cleans up both the metadata and the physical data files from the storage system. External tables. Spark only manages the metadata. The data files live in a user-defined directory outside of Spark's default warehouse. When you drop an external table, Spark only removes the metadata, leaving the actual physical files intact on the storage layer. Since running the command removed both the data files and the metadata from the file system, the table was explicitly a managed table. Why other options are incorrect? D is incorrect. As noted above, dropping an external table would leave the physical data file safe and untouched in your file system. B and C are incorrect. The physical deletion of files during a drop table operation depends strictly on the type of table, managed versus external, completely independent of the dataset's file size. Q30. A data engineer is auditing the infrastructure setup of their Databricks workspace to ensure compliance with organizational cloud policies. As part of this review, they need to identify which component is stored in the Databricks customer's cloud account than managed by Databricks itself. Which of the following is stored in the Databricks customer's cloud account? A. Databricks web application. B. Cluster management metadata. C. Repos. D. Data. The correct answer is D. Data. Why this is correct? Databricks operates under a decentralized architecture split into two primary components. The control plane, managed completely by Databricks in their own cloud accounts. It hosts the back-end services, such as a Databricks web application, notebook management, workspace security configurations, repos metadata, and the job scheduling services. The data plane runs entirely within the customer's cloud account, AWS, Azure, or GCP. This is where compute clusters are spun up and where all your raw files, databases, and tables reside, e.g., in an AWS S3 bucket, Azure ADLS Gen 2, or Google Cloud Storage. Because of the separation, your data never leaves your own cloud subscription or account, ensuring that you maintain complete physical ownership, privacy, and compliance over your datasets. Why other options are incorrect. A, B, and C are all hosted and maintained within the Databricks control plane, which is managed by Databricks itself rather than living natively inside the customer's cloud storage account.